Alright, some notes on our system of equations. The first thing, it says changing to slope-intercept form. Well, we know that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So we have our slope and we have our y-intercept. Now, how do we change from standard form to slope-intercept form? Well, what we really want to do, essentially, is we want to solve the equation for y. So if we just think about, well, how do we solve this for y? We have to get rid of the x, so we get rid of the x. And then after we get rid of the x, we divide by the y coefficient. So we get rid of our x, we divide by the y coefficient, and then that's how we get this in slope-intercept form. So when we look at this first example, we have 4x. You get rid of the x, so we do minus 4x, minus 4x. Cross this off, I bring down this entire thing, so now I have 6y equals, and I'm going to write the x first because in slope-intercept form, the slope comes first. So I'm going to say it's negative 4x because it's minus 4x. And this is a plus 12 because it's a positive 12. Step 1, I got rid of my x. Now I divide by my y coefficient. So we divide everything by that y coefficient. So y equals negative 4 over 6, x plus 2. And we know that 4 over 6 simplifies to 2 over 3. So we get negative 2/3 x plus 2. We look at example 2. Once again, we want to solve it for y, so we get rid of the x, so we do minus 2x. So we have 5y equals, I bring down this, so it's a negative 2x plus 20, and we divide by the y coefficient, which is 5. So y equals negative 2/5 x plus 4. So that's how we solve it for y. And now we want to leave this as a fraction because that represents the slope, and we know that the slope is rise over run. So that's why we want to leave it as a fraction, so we know that negative 2 over 5 is down to and right 5. So we want to leave this as a fraction. Well, the second example, the next thing we got to is the elimination method. Well, what does the elimination method mean? So when we hear elimination method, it means to eliminate. So we want to eliminate a variable. So we want to eliminate one of our variables. So the elimination method means we get rid of one of those variables. So we want to eliminate a variable. Well, how? Well, we have to make, we choose a variable. So we choose a variable. So we choose one, make them the same. We make them the same, and then one is positive and one is negative. And then we can add them together, and then add the two equations together. So if we take a look at this example, so we have 4x plus 6y equals 12, and we have 2x plus 5y equals 20. We want them to be the same. Choose the variable. So if I choose x, we have to make these two the same. So to make them the same, I'm going to multiply this by 2. That'll give me 4x plus 10y equals 40. But then you notice, well, one is positive, one has to be negative, so I change this to negative 2. Negative 4x, and then minus 10y equals negative 40. Now I can write this one below it. So if you notice, they're the same. One is positive, one is negative. Now I can add them together. I eliminate my x. So this gives us negative 4y equals negative 28. Divide by negative 4. Y equals 7. So now I have my answer for y, and once we know what y is, we can plug it back in to figure out what x is. So we just choose one of these two. So if I write the top equation, 4x plus 6y equals 12, and I know that y is 7, so now I have 4x plus 6 times 7 equals 12. Well, so 4x plus 42 equals 12 minus 42. 4x equals 30. Divide by 4x equals 7.5. So my solution, you get 7.5 and negative 7. Or positive 7, sorry. So we get 7.5 and positive 7. So that's how we get our solution. Actually, this is negative 30, so this should be negative 7.5. That's what it was. So 12 plus negative 42 is negative 30, gives us negative 7.5. And that's how we use the elimination method. If we flip this over, the next one is the substitution method. This means to substitute in for the variable. And we do it by, we solve for a variable. So we choose one of the variables we want to solve it for. So after we solve it for that variable, we plug it into the other equation. And then solve. So if we look at these, we have, once again, we have 4x plus 6y equals 12, and 2x plus 5y equals 20. We have to choose one of these, which ones we want to solve. So if we just do, and solve, I guess the second one doesn't matter. So if we solve this one here, we can solve this for y, which essentially we already did. So I have 5y equals negative 2x plus 20. Divide by the 5. Y equals negative 2 over 5x plus 4. Now, I solve for my variable. We plug it into the other equation. I take this and I plug it all in for this y. So we get 4x plus 6 times negative 2 over 5x plus 4 equals 12. Distribute. So this is going to be 4x minus, let's see, that's 12 over 5x plus 24. That equals 12. Now we can use our calculator. We can just combine this. Well, 4x minus that, we can change this to, that'll be 20x over 5 minus 12x over 5 plus 24. I gave them the common denominator of 5, so I multiplied this entire thing by 5 over 5. So this 8 over 5x plus 24 equals 12. Subtract the 24. So 8 over 5x equals negative 12. Multiply both sides by 5. So 8x equals negative 60. Divide by the 8, x equals negative 7.5. Once you get what x is, we have our equation for y. So y equals negative 2 over 5 x plus 4. We plug this in, so y equals negative 2 over 5 times negative 7.5 plus 4. So y equals, that's 15 divided by 5, so that's 3. 2 times 7.5 is 15, divided by 5 is 3. So 3 plus 4, so y equals 7. And then always the last thing I do is I write my solution. So the solution is x, comma, y. So that's the substitution method, where you substitute one variable in for the other. And then the last type of method that we talked about is the graphing method. And the graphing method means we graph each equation, means to graph each equation. Alright, and we can do this one of two ways. We can either graph in slope-intercept form, or we can determine the x and y intercepts, and then solution is where the two graphs intersect. So the solution is where the two graphs intersect. So if we use the x and y intercept, so if I have my first equation, which is 4x plus 6y equals 12, so the x-intercept, we say y is equal to 0, so we are left with 4x equals 12, x equals 3, and then the y-intercept, the x equals 0, so we're left with 6y equals 12 and y equals 2. So we have the point 3 comma 0 and the point 0 comma 2. 1, 2, 3 and 2. So here is this one. We'll connect it with a straight line. And then the second equation is 2x plus 5y equals 20. So the x-intercept, y equals 0. So we get rid of, so 2x equals 20, x equals 10, so that's the point 10 comma 0. So 10 comma 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the y-intercept, go right here. We know that x equals 0. So I have 5y equals 20, divided by 5, and y equals 4. So that's the point 0 comma 4. And once again, we see where these intersect. So 1, 2, 3, 4, 5, 6, 7 and a half. So this is x is negative 7.5, y is 7. So our solution is negative 7.5 comma 7. So if you notice, we got the same solution for all of these. This is just 3 different methods to solve the same equation. We have graphing, where we graph them. We have substitution method, where we plug one of the variables in. So we solve it, we plug it back in. And then elimination is when we get rid of one of our variables to solve it. And that are the notes for today. And if you have any questions, we'll go over them tomorrow.